Okay. Hi, everybody. Welcome to the Fusion Architecture YouTube channel. My name is Daniel Escobar, and today we have a great guest, Daniel Bolojan, and he's going to be giving us a quick presentation on creative AI from one to many. I'm very excited about this guest. I've been following his work for a few years now, since I think it was 2021 when Digital Futures during the pandemic hosted like a workshop, and he kind of showcased his research and work into generative AI in architecture, and showed us like very unique things at the moment, from using pix-to-pix, style GAN, and essentially how do you change these models to design a project. And that was really interesting and eye-opening, and it kind of pointed great directions or like interesting directions to use these networks or neural networks in a creative way. And so Daniel Bolojan, welcome. And you are the assistant professor and creative director of Creative AI Lab at the Florida Atlantic University. You also worked as a computational designer for what is it called, for Coop Himmelblau, and develop a project called DeepBlue, right? And
DeepHimmelblau.
oh, it's
Deep,
yeah, yeah.
I
Deep
wish
Himmelblau.
I wish
That,
I worked for Google DeepMind. Okay.
yeah, yeah. And you've been exploring the neural networks essentially in a very interesting way. I've been following your work, so I'm very excited to hear what you're going to showcase today. And then afterwards, we're going to have a conversation about where all this type of work could be leading to. So Daniel, welcome again, and the floor is yours.
Thank you, Daniel. Yeah, I think it's great. Like we were discussing before we start recording. It's great sometimes to also have some discussions about this that are a bit more informal. So today probably I'm going to try to keep it a bit more informal, not that formal of presentation. And what I'll try to do is just give a sort of try to present a sort of conceptual framework in a way why I think in a certain way about how I'm using these kind of networks. So for very long, in a way, I liked in a way always to be with one foot in one boat and with another foot in the other boat, meaning like I always like to keep my feet in this kind of like research, purely like speculative and so on, and then testing that research, teaching, testing it in practice. This is a sort of framing that actually was informed by Joseph Choma, who is our director here at School of Architecture, and also one of my colleagues, Manus Vermi. So this kind of approach of thinking about research where you do research, but then also you look at, doing research through teaching, research through practice, and so on. So I like in a way always to have my feet in one of these, just to keep me grounded in a way, because there are a lot of great ideas, but yeah, it's a question: are they really useful in practice? Yeah. So for a long time, I was very interested in these kind of ideas of intelligence. And I started early on with ideas of swarm intelligence and so on. And for sure, then also once I started to go into AI, that kind of idea of how do I encode intelligence in architecture, it's still present in a way. Yeah? So you'll see a lot of things that I'm doing. It's what I'm aiming for. I'm aiming for a creative AI kind of system that has a level of intelligence and it's able to actually engage in creative problem solving in a way. And that's also one of the reasons why this kind of ambition when it comes to intelligence is also one of the reasons why perhaps I have the approach that I have and my understanding that I have when it comes to neural networks. So I don't see myself necessarily as just an architect, and also I see myself as a programmer in a way. So I'm developing quite a lot of tools and deep learning networks for Coop Himmelblau. And I just like from time to time to also be an end user. Like I like to have fun with Midjourney or other kind of super powerful kind of AIs that are there. But I think my focus when it comes to research, I'm always looking at how can I build a system that actually it's intelligent and it's able to engage in this kind of creative problem solving. So I would like to touch on a few big points, and afterwards we can perhaps discuss about them. But initially, like for a long time, we had this kind of issue when it comes to intelligence. before we had deep learning, deep neural networks, this kind of problem where we were always considering that the problem why we are not able to solve necessarily intelligence or to have intelligent system is mostly because we don't have the correct hardware in a way to compute in a way that the necessary like computations to achieve that kind of intelligence, and then like quite a few years back, just very recently, we started to have all these kind of advancements in neural networks, and we started to realize that the actual hurdle was not necessarily a hardware problem, but it was mostly a compute problem. It was mostly like algorithms that we're using in a way to solve for intelligence rather than the amount of compute that we are throwing at it, And of course, recently we had some of super important attention is already paper that kind of revolutionized or made things explode even more. So before that paper, we had this kind of like GANs, CNNs, and so on, like that were trying to solve this problem of image generation or even text generation, so on. But then once this paper was published and we had this kind of transformer architecture kind of network published, suddenly things exploded literally in a way. Suddenly everyone's talking about AI, everyone it's in a way trying to think how they integrate AI in their practice and so on. So it's an amazing thing, So shortly after that, of course, we had this explosion of DALL-E, Midjourney, a party, and all this kind of networks. And more recently, we also have now text to image like Sora, GPTs, and so on. But they're all based on this kind of revolution in computing. So suddenly we had a type of neural network like a transformer that suddenly allowed us to actually scale up and to be able to process information at a massive scale. Until then, we had, for example, an example in AlexNet where probably the problem was mostly solved almost like through brute force, like just throw as much compute at the problem as possible, and you're going to have a network that kind of learns. But then once we had, in a way, like transformers, we were able to scale, in a way, the training and so on at a massive scale. And we were able to have these growth networks that achieved the performance that they achieved. So in the end, it was a revolution when it comes to computing, not necessarily a revolution when it comes to hardware. Although, like, in some aspects, they are synced, in a way, they go hand in hand, But when it comes to how you solve the intelligence problem, it was not so much a hardware, it was more a computing problem, Now, other kind of important things were these kind of ideas of, expert systems, learning systems. So recently, like since neural networks started to be more prominent, I think roughly, let's say 2006, when we had CNNs with young and so on. Until then, we had some approach to intelligence where we were trying to solve intelligence by hard coding kind of knowledge, and then having a system inferring knowledge and that kind of rule-based kind of knowledge that we encoded. While now with learning systems, we have learning systems that pretty much they just learn by example, and it's a sort of brain spiral paradigm. It's similar with the way that brains work. We just observe and derive in a way a representation of data that we're observing, and like that in a way we are able to infer in a way certain responses. And again, like this is just a simple diagram, like to show that. I'll try not to spend too much time because we want to just hit on a few important points. So this is again the example of AlexNet, but this was a super crucial step in a way because we realized that if we scale in a way massively the networks and the data sets, we can achieve a very high accuracy. And by the way, this is Ilya Sutskever, he was part of OpenAI until recently, but it was this kind of insights and this kind of beliefs that he had that scale is going to solve in a way the problem of intelligence. So that was his take in a way, like even here in AlexNet, it's like, well, can we scale this massively? So they scaled it massively, but they had to throw at it a lot of computation to be able to train this kind of network. While with GPT, because we have also like transformers and this kind of types of architecture now, we can scale things and we can really work at a very high scale when it comes to data sets and so on. But it's the same kind of mind and the same kind of idea. His belief that scale is going to solve that issue of intelligence. And we have now this kind of shift from something that Andrew Karpathy is describing as software 1.0 versus software 2.0. And in software 1.0, pretty much what we are doing, we are the ones defining the methods and the logic and so on. While in software 2.0, pretty much what you're doing, we're just designing a sort of simulation system, and then like simulation system as referring to a neural network, and that simulation brain somehow just starts to learn by itself. So we don't have to anymore like hard code solutions into the software 2.0. Now, another big thing or big topic that you'll see ideas to my research and why I'm doing certain things is kind of the idea from retrieval to generative. So this kind of retrieval computing versus generative computing. So if you think about like retrieval computing, what we are talking about is you have the data centers that, for example, when you use your smartphone, tablet, computer, you just send a request to a network, and that network is going to send a request to a data center to retrieve the information that you're looking for, and then you get the information on your device. So that information is somehow already existing. And now when we talk about generative computing, is this kind of interesting idea that whatever query you have, that query doesn't necessarily exist, but it does exist in sort of a latent space, let's say, of possibilities into a neural network. And then the network is just going to generate the response based on your query in a way. But the response itself doesn't necessarily exist. Now, other things
Hey, Daniel.
Yes.
Sorry to cut you off, but your camera went out.
Okay.
Yeah.
Let me check.
Yeah, sure.
So let's see. Is it back?
Okay, now you're back. Yeah, you're good.
All right. So now we have this kind of massive models, and we have the proper or better, let's say, algorithms to solve this kind of computing problem of intelligence in a way. But a bigger question then we have that are these models actually able to understand in a way the world that they are trying to represent? For example, if I'm training a neural network just on text, is that neural network actually understanding in a way the world that the network is talking about? Like, for example, GPT, if I tap in a way, generate for me a poem about landscape in the city or something, is that network actually understanding that world that it's describing there? And very often it doesn't. So it's and I'm going to explain just in a second why I think that. But if we were to say that, okay, so maybe just from a single modality like a text modality, model is not able to understand or to create a sort of representation of the world. What if we start to introduce like images, or if we start to introduce audio? Is that model going to be able to have an understanding of the world? And the more you start to add in a way this kind of modalities, the more a better picture in a way that model is going to have about the world. So what's happening is that also when we talk about this kind of amazing models like GPT and Midjourney, all these kind of models that are currently very, very popular, although they are able to produce work that exceeds for sure any kind of human capabilities, we cannot really say that those networks actually understand what they are doing, and understand in a more conventional like human cognitive process of understanding in a way what's going on. So for example, if Midjourney generates an image of a building, Midjourney doesn't understand what the building is, or it doesn't understand the structural properties or other kind of aspects that are super important. Yeah. So it doesn't necessarily have an understanding of the world of architecture, let's say. It has a very good understanding when it comes to representation as pixels and so on, but not so much understanding of the world. But if you were to say, well, if we start to add modalities, like multiple modalities, is that model going to have, in a way, this kind of property emerge, this kind of property where it's able to actually understand? And it's very likely, and many researchers, in a way, that's what they are looking for right now, engaging in this kind of multimodal kind of research. Yeah. And for me, this is interesting because also when it comes to architecture, I always saw, in a way, architecture from this kind of perspective. Architecture is a multi-system or a system composed of multiple subsystems that are interconnected, that influence and influence and influence other systems in a way. So it's this kind of very linked, in a way, dependency between systems. So when I'm talking about systems, I'm talking about, let's say, architecture speaking. So you have a functional system, you have a structural system, you have a enclosure system. So you have multiple kind of system in architecture that they have to somehow work together. So when we say we generate an image of a building, is that model actually understanding all those layers? And probably not. Yeah, it's highly unlikely that it's understanding. Although it's good to really intuitively kind of generate some very good examples. Yeah, but again, multimodality, certain things can be learned just through image. So here I'm just showing this kind of example of when it comes to the law of gravity, do we as humans understand gravity because we understand the law of gravity as a mathematical kind of equation, or how do we understand gravity? And most of us, I would say 90% of people, probably we just understand gravity as in we just observe how things fall, and like that's how we understand gravity. We don't actually understand the mathematical process behind it. So in that sense, are we being fair here, or are we trying to act something from the networks that we as humans don't do either? Yeah, as humans, we learn gravity like this by observing how objects drop. Yeah, if I release this object, it's going to drop, and I understand that it's because of gravity. Yeah, and it's interesting because you can learn that, these kind of ideas just through visual. You can learn a lot of things, and a lot of models are able to learn a lot of information about the world just through visual pixels. But still, there are certain levels of knowledge that are not necessarily just represented through images. So here is just an example of image models, image models being able to solve algorithms purely based on pixels. There's no algorithm information presented to the network, only examples of how to solve this kind of shortest path in a way. And the model is able to just learn to pixels in a way yeah. And there are also a couple of other models that are able to learn sounds just from pixels. So you're just looking at a set of pixels, and it's able to predict in a way what kind of sound is here. So, for example, if you have a piano or something, and suddenly it's able to understand that, okay, there's a piano, so the sound is going to be on the piano. Yeah. And this kind of idea, like also like Sora right now, we have one of the most capable models, but it's funny because they haven't released it yet. And there are so many already competitors out there that already released their text-to-image, text-to-video models. But what's interesting here is that just through brute kind of amount of data, like visual data, this model somehow learns a sort of implicit laws of physics in a way. Yeah? Just by showing enough examples, it somehow implicitly learns that. Yeah, and I'm going to talk about that just in a second, why that's happening. Yeah. So now, for me, then, when I'm looking at this, I don't see in a way the entire field, even in architecture, not only in architecture but also outside of architecture. I don't see it as there's going to be just one AI that's going to rule everything. I see it as, there are going to be multiple AI models that it's a matter of we as humans deciding how these models interact with one another. Yeah. So it's almost like we start to become designers of workflows rather than, just prompting one big AI model to solve everything for us. Yeah. Although, like, there are certain models like the recent release by OpenAI, the Strawberry project, yeah, like where you start to see in a way the model almost like reason and go through steps by itself. Right. Okay, but this is also a sort of understanding of intelligence where rather than thinking about intelligence as something that is very brain-centric, and this is a very, not all, but this was a very dominant in a way understanding. But Jeff Hawkins, he comes up with this kind of idea or this kind of theory about intelligence, where he's saying that intelligence is not something that is brain-centric, but intelligence is something that emerges as a consensus between multiple smaller brains. Yeah? So his idea is that, for example, when we try to describe what this object is, we have multiple sensory inputs that help us in a way to find what this object is. Yeah, so we have the visual, we have the tactile, the relation to the body, and all these smaller brains in a way they make or they create a consensus of what we perceive as being the object in a way. Yeah. So in that sense, he's saying it's not necessarily the brain that is doing all that. There are multiple smaller brains in a way that come together to come up with a consensus. Yeah. So for me, like this idea was something super interesting. Yeah, that when I started to look into, how to solve this problem of intelligence in architecture, I started to automatically see a sort of connection that also in architecture is not necessarily that you just have one big brain that solves everything, but pretty much you have smaller brains. In some cases, you need models that are highly specialized. For example, when you talk about structure and, evac and all those kind of like aspects that are more technical, you need super specialized AI models there, and you cannot afford like generative or you cannot afford maybe generative kind of models, or models that are hallucinating. You need like predictive models, or very deterministic models, And in our cases in architecture, you need models that are a bit more speculative and are hallucinating and so on, So it's not necessarily that, that we have just one system, We have probably multiple systems that have different degree of specialization or how specialized they are, And it's a matter of how the systems, in a way, interact and how you choreograph, in a way, the interaction of these models to engage in this kind of problem solving, So for me, then also I started to look at language models right now as architects. We are looking at language models as being simply just a text generator, But personally, I start to understand them more like computing interfaces. And if you think about it, even if you try to think about like how a computer works. So right now we have a context window when it comes to a language model. So it's you can think of it almost like a RAM memory, Daniel, like how much memory you can put into the system that is going to keep in mind or keep it as a context when it's going to give the response, So I see them more like this kind of computing kind of interfaces. And if you think about traditionally in software 1.0, you gave it a computer an instruction. You had a series of predefined methods and functions that are executed on your CPU, and then following a very precise human-readable code to produce a sort of result, So right now, like that's what's happening. Is just that we have very, very user-friendly interfaces, but pretty much that's what's happening with this traditional software 1.0. So this approach, I would say, it's very deterministic with every function outcomes being very meticulously coded by a programmer. Now, if we think about language models and neural networks more broadly, they operate at an entirely different or under an entirely different paradigm. So when you input a prompt into a language model, what you're doing, you aren't triggering necessarily a series of pre-programmed kind of steps, So instead, what you're doing, you're activating a network of weights that have been fine-tuned through vast amount of data, and it allows the model to generate responses by adjusting these kind of weights, So the code then that initially we had the code programmed by programmers. The code in this case then is not a series of explicit instruction, but a learned representation that is encoded in the weights of that network. So we can say that then this kind of new computing model, we can refer to it again as a software 2.0, rather than software 1.0. And it doesn't rely then on this programming logic, but it just learns in a way behaviors from data or learns intuitively from data. So just to touch a bit on this kind of idea, like right now we have a lot of models, massive models like GPT and so on, where I think there's a lot of discussion going around those, if those models are actually thinking or they're not thinking and so on. And I think a very interesting way to look at it is to look at it from this perspective of Daniel Kahneman understanding of, let's say, intelligence, where he's talking about the brain, or humans operate under two types of brains, a fast brain and a slow brain. And what he's saying that a slow brain, for example, is a brain that we have a lot of things that we already learn and we just execute on that. Yeah. So for example, I'm waking up, I don't have to like, again, think about how do I stand up and how do I start walking, how do I start dressing. I don't have to engage in a very rational kind of process of thinking how to do those things. Yeah, those are already learned. Yeah, those are already learned behaviors. So I'm just running inference in a way. I'm just running inference. I'm not just, behaving. But then if you're asking me to solve a specific problem that perhaps it's novel, I never faced that problem in my life, then suddenly I have to engage with a slower brain in a way, and I have to engage in a more analytical kind of process where I start in a way to judge in a way and to think more logically. Yeah. So what I mean with this, so personally, then I see, let's say, Midjourney, ChatGPT, DALL-E, all these kind of massive models. I see them as models that intuitively they learn how to solve certain problems. Yeah. So it's almost like all the part of thinking, it's already done. Yeah. So they learn during the training phase. And now what you're doing when you're inferring, that model where you're querying something from the model, pretty much what you're doing, you just, or what you just have a model that it gives you an intuitive kind of answer. Yeah. It's not necessarily engaging in a rational, process of trying to figure out certain things. Yeah. It's a brain, the system one kind of brain. Yeah. It's an intuitive, very fast in a way model, the same way that we as humans do. Yeah. But then the other side, we don't really have, although like just 2 days ago, 3 days ago, OpenAI, like they released their O1, or how it's called, model, which is the Strawberry project model, where the model actually tries to engage in a more rational kind of process, yeah, to try to solve a problem, yeah. So that's a sort of like, almost like they're trying to look into system 2 in a way, if we continue with this kind of analogy, yeah. And it's also this concept of intuitive kind of processing extends beyond, in a way, even design or various other domains, yeah. And if you think about gameplay, it's the same thing, yeah. In a very fast, in a way, game of chess, and many of you probably, if you're big fans of chess and you have it on your app, you can play chess for the entire day, one game, or you can say, I just want to have a 5-minute kind of game, yeah. So when you play that kind of 5-minute game, it's not necessarily that you're engaging in a very rational process where every single move you're thinking about all the other 5, 10, 20 moves ahead. What you're doing, you're just using a very instinctive, in a way, my camera, I think, went off again. You're using a very instinctive brain or system where you just take decisions in that game based on learned or pre-learned behaviors and patterns of playing the game. Yeah, I'm trying to start the camera while talking.
Yeah, the camera cut out again.
Yeah, I think it's maybe it's getting hot or something, and that's why it's turning off. Just let me put this back.
Sure.
Okay,
you're back. Yeah.
Okay, so I think it's the same like with all these kind of models, like Midjourney and so on. They are just very fast in a way, giving you a result, a response based on data that they learn in the training phase. Yeah, the same way like when we are playing a game of chess, and we have a fast, like 5 minutes game. What we do, we don't rely on this kind of slow system like system 2. But we are engaging in patterns that we already know that, okay, this is a good move, so I'm just going to do it very fast because I already know from my past experience, in a way, that that could be a good move. Yeah, so you just intuitively, in a way, take these kind of decisions. So I would say the same thing happens in a way with these kind of systems. Okay, so but what's interesting, and I started working with AI, or being more focused on AI than computation, as in agent-based systems, around 2016, something like that. So around that period, we had also this kind of massive news about AlphaGo that won against Lisa Doe. And this system, like it's amazing in the sense of like we are now 80 years in, almost like since this happened, and this system still has a lot of things to teach us in a way. Okay, my camera is keep on going off, so let me just switch. I need to switch to a different camera. Here we go. Okay. So for example, here, what happened is AlphaGo has multiple types of networks. It's not just one network. And in the first network, it's a network where pretty much it's only looking at examples of games, Go games played by humans, yeah? So it's learning in a way from that data sets of games played by humans, and it's able to really be very good, yeah? But the problem is that if it's only learning from examples from humans, it's not going to be able to exceed in a way or to go beyond the examples that it learned from humans. But then how exactly did this network went beyond and was able to actually come up with that completely new move in a way? And what happened is that this system is not only one network, has multiple networks. And one of the networks also, it's a network where it's a reinforcement learning kind of algorithm, where the game or the system start to play against itself, yeah? So you start to create this kind of fictitious kind of scenarios, and it starts to play against itself, yeah? And it starts to learn in a way, that kind of way. So it starts to go beyond, let's say, the initial data set that was mostly examples from how humans played Go in the past, yeah? So suddenly then you can say that this system was able, or the way that the DeepMind structure or designed the system, it allowed it in a way to have an intuitive kind of engine, which is just an engine that you learn from a lot of examples, and also allowed it to have a system that allows this network to grow with that, or to engage in a more logical kind of rational kind of process, yeah? And suddenly we ended up with a sort of system that is able to go beyond the initial data set. So it's not anymore just intuitive, it's also like starting to think about new scenarios, yeah? So this is almost like, for me, it will be, it's not necessarily perfect, yeah, for sure it's not perfect. We don't live in a black and white kind of world, but it's a good example of, okay, so the system has a system one, which is an intuitive, very fast kind of a system. And it also has an idea of a system two, which is a more slow, more intentional, more logical kind of side of it, yeah. And for me, this is then, this was one question that I was always asking in architecture, and I don't think, in a way, we have interesting people to address this. So since science is built up of facts, as a house is built of stone. No, sorry, science is built up of facts, as a house is built of stones. But an accumulation of facts is no more of a science than a heap of stones is a house, yeah? So I was always saying, this kind of idea, like, I don't think it's enough just to throw in away images to a model and then not even care about, like, if the model actually learns what you expect it to learn, and then just be excited about weird results that you get from this kind of networks, yeah? And in architecture, we have this kind of like weird obsession with, just put there something, make it weird, unfamiliar, and there we have it. We have an interesting design in a way. I would love to believe that actually we can design some systems that are more intelligent, and architecture can be more intelligent than just random accidents where we just mash things together and then, oops, an accident, and it's an unhappy accident, yeah? So the same also here. So personally, I'm more interested in this kind of aspect, like if I engage in a creative problem solving, and in this case, for example, we have this example of a way to move a massive block of stone is to put in a lot of manpower, like raw or brute force, yeah, and to try to drag this. Or you have the realization that if you place some blocks underneath that block of stone, you're able to transport or to move that block of stone more easily. But now that observation leads then to us understanding that if we're just putting some wheels underneath some objects, we can move those objects more easily. So we end up with shopping carts, with suitcases, and so on. And then we have also cars. Yeah, the same thing happens with cars. And one would say that, this generalization, this kind of idea, then also can be pushed even forward. Yeah. So we can start to understand that, well, if we reduce the friction between the object and the ground, let's say, we can end up to, let's say, Hyperloop, yeah, where we reduce completely the friction between two objects. Yeah. But this is, if you were to say that I'm just going to train a network based on images, so you're going to show the network a bunch of examples like the first diagram over here, where you just have raw power, and you cannot make a claim and expect that the network is going to know that, hey, if I put a log underneath, that's going to solve the problem. Yeah. So you need, in a way, a system that actually starts to understand that. Yeah. And for my opinion is that to get to that kind of system, you need, in a way, a multiple neural networks. You need like an interconnected system that is able to engage in something that we might call, even if it's not perfectly, if it's not the same like the way that we engage in that process, but we can call it a sort of reasoning kind of process. Yeah. Okay, so what I'm going to do is I'm just going to go very fast in a way through some examples, just to see, to show you how these kind of ideas kind of apply in this kind of research that I'm doing, and also with some students. So we're quite a lot in. So I'm just going to go very fast through this. So here is the Sagrada Familia project, and here is the same kind of idea, like just a system by itself, just showing just a bunch of images is not enough to, in a way, to understand the complexity of an architectural project. And for that, then you have to, as a architect, you have to start to think about like which are the processes, or which are the nodes, the network, or which are the design elements, in a way, that are important then to be addressed. So I have to break down the problem into sub-problems and think about like which is the proper method, tool, network to use to address, in a way, each of those problems. Because some of the problems, they have a more general kind of aspect. Other problems, they are more specific. So how do you do that? So here in this case, I have multiple networks, in a way, that try to approach that. Other kind of ideas here going along the line of world models. And I'm thinking about this kind of idea of like, can we have our own semantic like a universe, almost like a semantic world model that we as creatives, we define for ourselves? And if that's the case, then of course, like how do you build up that kind of semantic universe? And here, for example, typically what we do as designers, we are always engaging in this kind of collection of sketches, sections, drawing, 3Ds, and so on, examples of spaces and ideas that we actually find interesting. And those are helping us in shaping our understanding and our own style, in a way that when we generate something, when we create something, it's going to be, in a way, expressed. Yeah. So here, just a very simple example where I'm looking at purely just aesthetical aspects that I'm interested in that have nothing to do with architecture. I'm just interested in conditions. For example, I have here patterns that are more, they have this kind of gills-like, more porous kind of, more branching kind of patterns and so on. Yeah. So I like those kind of conditions. So how do I train, in a way, a model semantically to understand that? And then perhaps can I use that information to now transpose it into architecture? Yeah? So here then you have a couple of examples of how that kind of model that was not defined necessarily for architecture, but it was mostly a semantic model. It's able now to be constrained to a sort of architecture domain. Yeah? So here you have that example. Now, in many aspects, like, I cannot really show everything just because there are a lot of processes going behind. But I can show you one example just to understand the depth in a way of processes that go behind. I'm going to show you. So this is the Creative AI Lab at school. I'm just going to skip over. So I'm going to show you a project that we developed with students here, just to show you an idea of how the students in a way approach the idea of like building a semantic universe in a way. Yeah? And here, like the way this is done, then like which are the different parts of the design process that have to be in a way split into tinier processes, and which are the networks and the tools that are required to be used for those specific kind of processes. Yeah, and in the end, you end up with this kind of like massive kind of workflow. It's almost like a thinking kind of logical kind of diagram that this kind of system has to engage in if you want to have a sort of semantic universe that you're able to build, and then you're able to use. Yeah. So here, like the way that the students, they start to define which are their references, which are the semantic information that they want to encode in a way in this kind of universe that they have, like how exactly you're matching your own understanding of those semantics with the understanding of the network. So how do you analyze in a way, and yeah, how do you analyze also the textual descriptors and also the visual ones and also the 3D ones and so on. So there are multiple then processes that have to be run behind and optimized in a way to have a semantic universe that actually it describes the kind of aesthetics that you're interested in. Here we are also having this kind of heat maps that allow us to measure in a way how close in a way the model is trained to our understanding and to our semantics that we are looking for, and especially descriptors. Are the descriptors, textual descriptors, corresponding to the visual kind of features, or they are off? Because for example, for me, when I say curvilinear maybe for me doesn't mean Zaha curvilinear. So right now in Midjourney, for example, when you use a descriptor as a curvilinear, you're getting Zaha 100%, yeah, or very likely you get Zaha. So for me, curvilinear, it's a different kind of curve, yeah. So how do I encode that? How do I train networks then to understand in a way the kind of design sensibility that I'm interested in, yeah. So then in the end, this kind of system, yeah, like I'm not going to go into all the details, but this kind of system, then you have all these processes where in some aspects you have intuitive kind of models, and in other aspects you have models that try to engage in a sort of reasoning kind of process, yeah. And the last one, and I'm going to go again fast through this, is the DeepHimmelblau project. And this is a project that, I'm developing for CoopHimmelblau. And from the very beginning, the idea here was this kind of understanding of architecture cannot be collapsed in a way to only representation. We cannot say that if we just use image-based models, that's going to be enough in a way. So we started to look in a way more holistically in a way at the entire problem. And we started to look at how can we have like different nodes. Yeah, we call this a node-based system. And we try to address like specific or different kind of aspects in architecture. For example, Gestalt pretty much deals with aesthetics, with 3D objects generation and so on, while organization deals with massive models, functional aspects, technical deals with optimizations and so on. Yeah? So all these kind of aspects, they have to be addressed, and you have to have a system that addresses all this if you really want to have a system that in the end gives you some results that are credible architecturally. If not, like, it's not to say that Midjourney is not creating credible results, but remember what I was saying at the beginning, like just because it's generating an image that doesn't mean it understands the structural implications and so on. And this is very typical also, like we as humans, as a designer, when you just sketch something very early on, you sketch something. When you start to sketch something like a conceptual drawing, it's just an intuitive kind of drawing. You haven't considered in a way all the implications of everything. Yeah, only afterwards you start to engage in that kind of process. So and only after engaging that process you can say, okay, I'm building now a building, and that becomes sort of architectural piece. Yeah. But again, we are influenced by this idea of 1,000 brain theory, like how multiple networks have to be connected. Each network has different scope and different level of how general they are. As you can see here, there are a couple of, I'm just showing broadly a couple of nodes that we have. We have nodes that are more technical, environmental. And here, environmental, for example, we are not looking necessarily at extremely precise ones. We are looking at, can this kind of method be used early on in the process so that we don't have to model things digitally, only after that run a solar analysis, for example. Yeah? Can we have the solar analysis very, very early on, where we just have a physical model, for example, and we have the prediction there, yeah? Now, another thing that, lately I've been pushing a lot is this kind of idea of the text-to-image model, like a diffusion model. And we are trying to show that there are strong biases, in a way, in the models that are out there. And we are trying to show, in a way, that you can, as an architecture office, you can train your own kind of neural network to be more aligned with your own aesthetics and styles. Yeah. So now I'm trying to address this question because I know many people are asking this, like, so what are you guys trying to do? Are you trying to create this kind of knockoff kind of examples of your architecture of your buildings that were already built, or what's the goal here? Now, the idea is that, for example, for somebody to dance, they have to first prove that they're able to stand up and they are able to walk or do something, yeah. And only after that you can say, okay, now you can engage in a sort of body kind of behavior that is more intricate than just moving. So for us, in a way, when we show these kind of results, we are just trying to show them as validators that the network actually is able to understand our style, but it's not necessarily used as a way of, let's just create another replica of our buildings, yeah. So here, yeah, let's skip through this. Just a couple of other examples. But what I like to show is, I always like to show progress. So, all these models were done probably 3 years ago, 2-3 years ago, something like that. And the more you go through the presentation towards the end, you see they are getting better and better. So right now, this was something at the beginning of this year, and we are getting better and better and better. Now, another thing that, personally, I'm pushing always for, as architects, we have to become developers in a way. Yeah? I think architects for so long, we love being end users, and we don't want to get out of that kind of mode of just being end users of whatever other industries are producing. For example, I'm showing you this example because it's still relevant, and I'm shocked in a way that it's relevant because I showed this publicly like 2 years ago, this kind of method where in architecture, we have this problem that, if I generate an image, I want to be able also to generate perhaps the sides of the same building in that initial image. And a lot of the models that we have out there, they're not really able to do that, yeah? And the problem, why? Well, why would we Journey, in a way, care about architecture? We are not their main customer in a way, yeah? So there are other industries in a way that are more relevant for Midjourney to focus on and to implement different features and stuff like that than to think about like, let's solve for architects this need that they have, yeah? So for me, it's like, then as architects, we have to engage in this kind of process. Yeah? We have to become more than just end users. We have to become developers in a way. So here, just an example of, you have a model that is able then to, you can prompt in a way, like, I want to have the same building, but I want to have a different side of it, yeah? So you have here, this is an example from about 2 years ago. This is an example from this year, yeah? So where I can almost like literally turn the entire building and I can have a prediction of the same building, yeah? And this is also something that helps when you have a lot of 3D data sets. It also helps you to create predictions of objects. So here, then we can also have this just an image. Based on that, you start to get predictions of 3D, and that's also interesting because it's a similar process with what we do as designers. We have a sketch, and then you have each designer kind of giving a different interpretation to that sketch. Yeah? And the last one that I'm going to show is also this side of like, how do we bring feedback back into the training process? Because right now, we don't want to just have the network always be a step behind in a way. Can we have the network somehow learn while also users are learning and generating data? And this is an idea that we're implementing when it comes to that, something called federated learning, where you have multiple instances of models on different computers. And you can, in a way, have the models kind of learn from the local data. And then once the model is trained locally, you can send the weights into a pool. That pool creates a consensus, and then it's being sent to the main network. Yeah. So this sounds very familiar with thousand brain theory. Yeah. So that's why I was trying in a way to show at the beginning, like all these kind of big main kind of conceptual ideas, because a lot of the work that I'm showing here, like through research, through Coop Himmelblau, they have all these kind of ideas in the background. Yeah. It's just that it might be that, it's hard sometimes to talk about all those ideas. Yeah. But yeah, that's pretty much it then for today. Perhaps that's enough to start a discussion.
Awesome. Daniel, thank you. That was a great lecture, and I'm really excited to see this type of exploration from like a theoretical, kind of like the brain theory aspect of it, which it makes sense, right? Like at the end of the day, it seems like we are getting to the point where like these networks are going to be talking to each other in some way, right? And we'll have these general purpose models like OpenAI or Google's models, and then there'll be more highly specialized models that need to talk to those bigger models, right? And maybe like I guess like so we'll start like a little bit more of a conversational part. But what got you interested in using AI for architecture? Like how did you arrive at this, essentially?
I arrived to AI by necessity in a way, or because of necessity, let's say. So if you
Hmm.
remember at the beginning, I was saying, that I have this kind of I had this kind of desire to encode intelligence in architecture. Yeah? So early on, like let's see if I can jump very fast there. So this is even since I started studying with Zaha at the Angewandte, this was one big drive in a way for me, like how do I encode intelligence in the design process, in architecture, and so on. Yeah? And back then, 2008, 2009, back then
Hmm.
it was mostly, computation-wise, we had progress when it comes to Grasshopper. Yeah? So I was looking mostly at Grasshopper. How can I use Grasshopper in a way to engage in this kind of process and so on, and to engage in agent-based systems with Grasshopper, especially back then,
Yeah.
it was so difficult. Yeah. And what I started to do is I started to say, okay, so which is a different platform that I can use then to engage in this kind of processes. So I started looking to Java. So suddenly I had to start to learn Java in a way. Yeah? So this is also something that a question that a lot of students are asking me, like, how did you know so many things, so many softwares in a way? And I always tell them, it's not that I didn't learn them because they're fancy and they're in vogue or something. I learned them just because of this kind of necessity. I was trying to solve a sort of problem, and I thought that tool is the right tool in order to solve the problem. Yeah. So I started using Java. Yeah. So Java, of course, gives you more freedom than a Grasshopper, and you can run larger simulations and so on. But then the problem
Mm.
with Java, it's also Java, you'll hit a sort of a ceiling, and you're running computing problems. You're running into, well, you don't have strong enough computer, so you're not going to be able to run more than 10,000, let's say, agents kind of simulations. And they're not really relevant then, because, well, I don't want to just create architecture that leave behind traces and that's it. Yeah, I want to create perhaps an architecture like one of the examples, for example, here, you see the facade project here. So the facade
Hmm.
project there, every single vertex in that, or vertices in the mesh, it's a sort of agent. Yeah. So how do you engage that in that kind of complexity when you don't have enough compute power? Yeah. So what I started to do is, and this is thanks to, and this is shout out to Shajay from Zaha. So Shajay, they gave, or Zaha called, they gave a lecture or a workshop actually at the Angewandte, and they were showing in a way how they use CUDA, in a way to speed up in a way processes in the office. Yeah. And that was for me like a moment where I was like, wow, so I can use parallel programming. I can use like, instead of running all these calculations that I'm trying to calculate with agent-based system, instead of running them on CPU, I can run them on GPU. So I started learning in a way how to write code for CUDA. And that was fun, yeah, because it really speed up like a lot, the entire process. So I ended up like, massively expanding it to million kind of agents and so on. And that was cool, But one thing, again, very practical speaking, one problem with that was that to write CUDA code is not the most pleasant thing to do. It's not the nicest. Yeah, it's not that easy. Yeah, like
Yeah,
it's almost like
that's
you write
that's
in
really
C.
like
Yeah,
deep in the
exactly.
computer, like deep in the machine there. Yeah.
Exactly. It's almost like you write in C, it's like, it's quite tough. Yeah. So I started thinking of it like, then rather than trying to write all this kind of code to calculate all this kind of proximity checks and this and that, is there a way for me to predict perhaps locations of agents? Can I do, rather than trying to hard code like methods of calculating, can I predict perhaps? Yeah. So that was the point where I started to look into statistical learning. Yeah. So I started to look at statistical learning and ways of predicting things perhaps. And that's purely just statistics. Yeah. Just sort of like machine learning kind of things. Yeah. Like tools and so on. Yeah. But then once I started to go down that road, like suddenly I started to discover all these new ideas about, so you can encode intelligence also this way and that way, and they have these systems and neural networks and that and that. And suddenly, I found myself in a way, completely new. It's almost like that kind of moment where you go through the bottleneck, and then suddenly you're finally out, and now you see all these kind of possibilities. So I think that was for me, that kind of moment where I started to shift from hard coding or programming things into like looking at predictions, models that start to learn, and suddenly then you find yourself in this kind of vast universe of possibilities. So then slowly I started to move more and more and more in this direction.
Yeah. And how do you see, I guess, from like that point in time where you were essentially just getting into this area to what now, and you spoke about this, like OpenAI's like recent release of like Strawberry, which is essentially like, or it's supposed to be like a big improvement on reasoning capabilities of these models. How do you see this? Like, and like, do you kind of see, okay, well, we arrive here now from like, I don't know, like let's say like the last 10 years, this is kind of like the most advanced AI technology at the moment. What do you think about that? Like,
It's amazing. Like if you would have asked me like 3 years ago, like
yeah.
probably I would have said, we are still 10, 20 years away from actually having these kind of AI models. And yeah, I was blindsided. I haven't seen in a way like what OpenAI is doing, although I was following them, and when they started to create this, sentiment analysis kind of networks and so on, I was always looking at that kind of research. But somehow, or everyone I think got blindsided.
Yeah.
Let's say, everyone got blindsided. And suddenly you realize that, wow, actually we are so far ahead, when it comes to this. And now that I'm paying more attention to these kind of things. A lot of the research is so far ahead already than the things that are public or accessible to everyone. Yeah? There's so much research being done that is so much far ahead than what we have. But I think it's super exciting now for me. It's like I'm a how are they called? D cells and S cells or X cells. Like I'm all for acceleration, yeah.
Yeah, yeah.
So for me, it's an amazing time. Like it's exciting in a way, and I see it as I know many people think that this is going to be a sort of people are going to lose their jobs and all this, which yeah, in some aspects for sure might happen, as it happens with any kind of technology. But I still don't see it as like, for example, you have Midjourney, and I don't want to be very critical, but if I scroll through my newsfeed, I cannot really
Yeah.
say that I find a lot of amazing results with Midjourney. Of course, I'm amazed by the high quality of the image, but it's not necessarily that it's super amazing as an idea and concept and all that. Yeah. So even if we have, it's almost like to say I have a brush, or actually everyone has an access to a brush right now, like physically speaking, like a brush, yeah. But not everyone it's a genius when it comes to painting, yeah. And I think the same thing also with this kind of tools. We are going to all have access to them, but in the end, it's up to us, like how we use them, yeah. So I don't see it necessarily as replacing. It's in the end like a method that you can choose to use it in a very novel way and really push things forward. But if you limit your imagination and you don't try to come up with something new, how you use these kind of tools, probably you're going to be with the same problem like before you had the tools. It's about the imagination that you have. It's not so much the tool itself. The tool is just enabling us to do those things,
Yeah, and I think like at least so I also learned how to code maybe like pre GPT era, and now at least being able to like having to go through like the hard process of learning how to code like Python and so on and like all these things. It was hard, right? Like when you started from scratch to code neural networks and stuff like that is really hard. And now we're like at this point where you can essentially just like put it into GPT. It can read through documentation, tell you what the code is doing, and it speeds up this. Like if you already have some knowledge, like it just speeds up like how fast you can go. And it lets you like experiment more, or at least I find myself like having that ability of being able to experiment a lot more with code. Um, do you find that as well? Like, is that something like you're seeing these tools essentially making you more efficient at doing certain things? Because I do think that um, they don't replace like what you want to do. They just kind of like make you more efficient in some ways.
Yeah, for sure. Like I see it in the same way. Like you can suddenly 10x in a way your output, and you can really advance very fast in a way. But I'll make a comment there, like in terms of even when we only had image models, like and this was a discussion also in Coop. Like for me, in a way, I can use the network in a certain way because I have certain design sensibilities. Yeah. But if I were to give exactly the same network to somebody else that doesn't have, in a way, that sensibility or the knowledge that I have, it doesn't matter. The results are not going to be very good. Yeah. So it depends a lot on what I know. So for example, also coding. Is it true that everyone or anyone can just go in GPT and just say, create a code for this for me? Yes, everyone can do that. So but okay, so everyone now is going to be able to generate like this basic kind of scripts. But how do you create something that more advanced, something that actually really addresses a very tricky, complex problem? Yeah. So you cannot really just describe the complex problem to the GPT because it's not really able to understand all the complexity of it. Yeah. So you have to break it down in a way into bits. And suddenly then, because you already learned programming before GPT and so on, for you have an advantage in the sense of, well, I know that I have to ask for, hey, you have to create an interface. You have to create a class. You have to create a method. You have to create a function. You have to combine this way, So when you're prompting now the GPT, I know how to prompt it because I understand in a way like the logic of how that script is going to work, yeah. But if you don't understand that, for sure you're able to still to engage and perhaps learn along the way with GPT. But for sure, at this point, if we were to talk about today, like the person that has the prior knowledge, of course, you're going to be able to speed up way faster than the people that don't. Yeah. Now, for sure, the things are relative in the sense of to the starting position. Yeah. Your first year, we cannot compare your first year to my 10-year. Yeah. So for my 10-year, my knowledge of 10-year, let's say, apply GPT, of course, I'm going high. For you, first year, you apply GPT, and of course, you go high in relation to your knowledge, yeah. You're also like growing anyway, but also the other people are growing, yeah. So I see it as, if you already have knowledge in programming, I think this could be almost like exponential kind of increase in performance. Yeah, you can really do so much. And there are a lot of like softwares out there right now that they have AI enabled, and suddenly you can engage almost like a assistant with these AIs. So for me, like right now, like the only limit is you. Yeah, and I think we are going to slowly get into that world where the only limit is the questions that you're asking and your
Yeah.
imagination. Yeah. And I think we will have to learn like how to ask questions, you know, how to ask more questions, because the more you ask questions, the more you're going to learn from GPT and so on. Yeah.
Yeah, and it's almost like the whole process of like if you are using these models in some sort of multitask or a little bit more complex task, you kind of have to be clear on your goals, right? And you have
Yeah.
to like learn how to write and clarify things a little bit before
Yeah.
putting into the model. So there's also that of like helping you clarify your thoughts. And let's talk about a bit. Okay, so like you're having the
Can I just add something there just
yeah, yeah,
for a second? Like,
sure.
so when we talk about GPT and programming, in a way, that's the part where, you know, you start to perhaps have a different understanding of GPT than if you're just using it to write text. Yeah. So if you're
Hmm.
just writing it, if you're just using it to write text, you can very easily be fooled in a way that what you're getting is actually something that makes sense. And what I mean by that is, if you say like generate for me a poem, so it's very easy for GPT to create a poem, but it's very hard for you to evaluate how valid and how valuable that poem is. Yeah. So it
Hmm.
can generate for you a million poems, and you're going to look at all of them, and you're going to consider them all valid. Yeah. Because it's very hard, like which is the way how you're judging, you know, if the result is good or not. Yeah. Now, the same system, when you do this with coding and you're saying, create for me a code that does this, and GPT is more than happy to give you that. And it's like saying, yeah, you can use this code and you can use it. You take the code, you put it into your editor, you try to run it, and you get errors. And you're like, what happened? I looked at the script. GPT gave it to me, and it read right. Yeah, I read, you know, the entire like functions, methods, and all that, and it felt that it's the right answer. You try to run it in a very objective manner now, yeah, because it's either running or it's not running, yeah. So there's no like subjective kind of thing, like it's either running or not, and you realize it's not running. So what happened there, you know? Like, so that means a lot of results that I'm getting, you know, if it's something that is not very objective or something that I can evaluate very objectively, a lot of the results, you know, what we call hallucinations, a lot of results maybe are nonsense. It's just that our ability as humans to actually grasp the result is maybe very limited, and that's why we are not able to catch it. That actually what we got is not making sense. But when we do that through coding and objectively trying to run the code, we realize that the script is not compiled. Yeah, it's not running. So that's something, you know, that a lot of people, you know, like they praise all these neural networks, which again, I'm super pro. And we have to understand that, okay, they have their own limitations. And also with coding, you know, then how do you ask in a way to solve that problem? Do you understand what's the problem? What's the error? Or you're going to just copy in a way the error. You can copy it and you can go in this kind of like almost like chasing your tail. So I did this once, like where I didn't say anything to the GPT. I was just putting the code in,
Yeah.
try to run it. Okay, I'm getting an error. Just copy the error, put it in GPT. It's going to generate a new code, take the code, put it, another error. And you keep on doing that. And at one point, you find yourself to the first error. Yeah. And it's like, what's
Or you
happening?
get another error,
Yeah, what's
which
happening?
that
So that's a sort of question of you have to then to understand in a way the problem that you're trying to solve and what might be in a way the problem. And once you understand, like, you know, what might be the problem, why you get that kind of error, you can suggest, hey, perhaps this is what's happening. Yeah. So then suddenly GPT is looking at it and it's like, ah, you're right. And it's giving you a code and you're putting it, okay, now it's wrong. Yeah. So in that kind of sense, I think, you know, right now the GPTs that we have, you know, they have their own limitations, but for sure they are like super helpful. Yeah.
yeah. And it's also like what you're saying is like it is definitely hard to discern like if it's just spitting out things. Just the velocity of the data that can give you as a human, we can't like take that in essentially, right? So there's
Correct. Yeah.
sort of this limitation that we're encountering with the velocity that it can give you data. Um
And
now
also it's your window context in a way,
yeah.
like really you get like 2000 words from GPT, let's say. So are you going to put all those 2000 words in your head and be able to analyze them at once? you're not able to do that. Yeah, probably
Yeah,
you're
it's
able to have
impossible.
one paragraph and then look at a different paragraph that GPT gave you and another one, and try to compare them. But you don't have, that capacity in a way to keep that much information in your brain at once and then try to analyze it. Yeah. So that's why it's hard in a way to grasp, like if it's really the result, if the answer is really good or not.
Yeah, and I think one of the I guess like topics that I keep seeing popping up is the idea of essentially these models as humans is like really hard, like because we have like you said, like this context window. But if we have like a large variety of data that's unstructured, the idea that these models would actually help with that, right? And we're seeing kind of like deployments of like using ChatGPT or whatever into just business use cases where they can take all the data from like a business, um, and then you can just search through that data. You mentioned like the idea of retrieval and generation as well, but being able to search through all this data in a manner that essentially is much quicker than what a human would do and how many clicks a human has to like go find some data somewhere hidden. How do you see, I guess, like that affected maybe just like architecture practice in general?
Yeah, for sure. Like, I mean, there are already some companies that I'm talking with about these ideas, and in the end, what you are going to have is not going to be pure only generative. It's going to be a mix, and depends. Yeah, like depends on the problem you're solving. And you see, like, we have Excel. Excel is still an amazing software.
Mm.
It
Yeah,
doesn't
yeah.
matter how old it is. It's so. I mean, is there another better alternative? There's not. You know. So
Mm.
or not that there is a none, but like for the general public in a way, like it's much easier for everyone to use it. So I think also like there are certain methods that yes, they are going to still be here, and not because they are like these kind of lingering kind of things that you cannot get rid of them, like a parasite or something. Not necessarily. It's just because like that's the most practical and efficient way to do or to solve that problem. So then retrieval, like yeah, we are still going to have retrieval. It's just going to be a more speed up in a way and more effective kind of data retrieval. Yeah. So it could be that businesses, you're going to have not only one GPT, you're going to have multiple GPTs. Yeah. So this doesn't have to be now GPT. It could be a Llama or something, like open source kind of models. But you're going to have multiple, and you might say, I'm going to have a GPT for legal department. I have one for construction. I have one for regulations. I have one for this or that. And then it's a matter of like when I'm asking a question, so maybe I have all this, and maybe I have another one that is more general. So when I'm asking the general one, like, hey, I'm trying to solve this problem, the general one would be that is going to say, well, this question that you have has also something that we have to be aware when it comes to legal compliance, this and this, yeah. So it's going to look then at your query and it's going to search, okay, what about legal? So how are we as a business addressing this kind of legal questions and so on? Yeah. So okay, that's how we are addressing. So I'm extracting from there then and giving you the result or the answer. The other one. Yeah. So I think it's mostly going to be something like that rather than just thinking that it's just GPT and just generative AI. Yeah. It's going to be like a mix, and I think it's good to look at it as try to look at which is the problem you're trying to solve, almost like a first principle thinking, which is the problem you're trying to solve, and then which is the proper tool for that. Yeah. There are still like a lot of neural networks that no one is talking about right now because they are not in vogue anymore. But that doesn't mean
Mm.
that those are not the best type of network for that specific task that you're trying to solve. Yeah. So it doesn't mean, and this is something that as humans, that's what we do all the time. It's kind of almost like fallacies, like just because the only tool that you have is a hammer, that doesn't mean that everything is a nail. You know. So
Mm.
there is a tendency, yeah, like right now, to dismiss all the past models and just say only generative, only diffusion, LLMs, transformers based kind of models. Only those are valid. No, like depends on the depends on the task. For example, if you're a small architecture office, you cannot have an LLM or you cannot train it your own. Probably you need
Yeah.
open source one, or maybe the problem that you're trying to solve has nothing to do with LLM. So maybe it's enough to use just a conventional neural network and a CNN, and that's it. But you have to look at which is the right way tool for the right problem.
Yeah, and now let's talk about a little bit of architecture intelligence because it's I think you're kind of looking at this now. How do you implement, at least with the last few projects that you showcase, how do you implement architecture intelligence, or how do you encode architecture intelligence? How do you use it to generate something new? And you showcase the Himmelblau project, where you're getting these diffusion networks. I don't know if you're using diffusion, but to generate like multi-views of space, right?
Yeah.
How can you maybe talk a little bit about that, and like how do you see this evolving essentially? Like where do you see this going eventually?
So for us right now, like I was saying during the presentation, like for us, it's not so much those qualities, not so much to show that it's not that we are trying to replicate our own kind of buildings. Yeah.
Mm.
When we are showing these kind of results, is mostly to show that hey, the model is capable, and then the way that we are going to use it, it's a different question. Yeah. Because we are going to have models that are able to address perhaps certain aspects of design that are a different level of abstraction than the final high resolution kind of details. So can I operate at this abstract level? And let's say messing, because everyone understands messing. Yeah. So can I work at the messing level while also being able to see the impact that messing will have on the final one? Yeah. So can I have like multiple these kind of models that allow me to almost like interject in a way in this process of generating building? Can I interject into that and start to say, okay, no, we want to have this system or this level more in this kind of direction. Okay, you change that, but you have down the stream everything else that updated to it. Yeah. So keeping in mind all the relationships and all the things that we establish. So it's a sort of intelligent system that is able to understand in a way how those relationships, if I change the massing, then which are the implications of those changes on the other aspects of the other systems, yeah. So it's able then to process it in a way that way, yeah. So I'm thinking of intelligence, of course, from that kind of perspective, yeah, a system that is intelligent enough in a way to understand that, but then also a system intelligent enough to understand a sort of problem solving, yeah. So I can give you some metrics of what I'm looking for, and can go through a sort of iterative process. And once you have the system set up as a sort of node-based, you're able to do that, yeah. If you just have it as, I just have a network and I'm trying to, a GPT and trying to force it to give me something, it's not, you cannot really end up with this kind of iterative kind of generative process, let's say, yeah. But if you have a sort of node-based structure of things, and by the way, I'm going to make some announcements soon about this new ideas about some projects that I'm working on that I haven't made public, but I've been working on them for some time. But yeah, once you have this kind of nodes, you can establish like which nodes address or which are the things that you're interested in to solve, which are the criteria, the metrics in a way that you're interested in, and just as a system to start to evaluate that, yeah. But it's not anymore like a sort of system where I have to define the rules. And so yeah, what I'm doing, I'm just saying these are aspects that I'm interested in, like aesthetics. So you have to run some aesthetic evaluation. I'm interested in this aspect, like performance. You have to run some there, and then keep on iterating until you get to some plausible kind of solution.
Yeah, and this this kind of reminds me a little bit of I've been messing around with the GPT like agent store, let's say.
Yeah.
Where there's like people creating kind of like these different types of GPT models that do one thing. Like one can generate diagrams, the other one can do kind of like auto search or something like that on the web.
Yeah.
Is that, I mean, it seems like that's something similar to what you're talking about. It's that like you're
it's a similar
essentially
idea.
connecting them, right? You're
Yeah,
connecting them so it works in an architectural setting.
Yeah, it's a similar idea, yeah, where it's almost like you're specifying in a way. These are the type of nodes that I'll need to work in this setup for this problem. And
Mm-hmm.
then you just allow the system in a way to figure out, okay, which node with which one, how they have to be in a way connected, or how do they have to be evaluated. So based on that, then you have a system that by itself, you know, it tries to figure out a solution. Like, but yeah, there are a couple of a lot of interesting ideas like this kind of, I think it's called agentic AI. There
Yeah.
are a lot of interesting ideas there that for sure in a way like personally I see that more interesting than just relying on massive models. And again, you know, it's just because of this idea of even as humans, you know, in a team, you need somebody that is highly specialized, and you need somebody that is more of a generalist, because the specialized people they miss the point many times. Yeah, they miss the point of, you know, what you're trying to do. Then you have the general person, or more general, somebody that has a more general view, bigger picture kind of person, and those are able then to, okay, hey, yes, I don't understand all the details, but this is the big picture, you know, that we have to keep in mind. So I think it's the same. I'll use that kind of analogy to explain this, you know, these kind of processes. Yeah, it's always you always have to shift between different levels of abstraction, different levels of precision, you know. So it's never like I'm always super precise. If you're always super precise, you end up with probably super conventional kind of outcomes. If you're too speculative, you end up with things that cannot work. So it's always this kind of like, where do I choose? And this is something that as humans we do all the time when we design. Like you have to make this determination that right now, whatever I'm drawing at this level of abstraction. It's not that I'm ignoring like details about, you know, how it's going to be built, but at this specific part, I have to work at this level of abstraction to understand the problem. And then I can switch and change the level of abstraction. Yeah.
Yeah, and I think you had a great diagram that I've actually never saw before, and this idea of like being able to pull the block and then being able to add, it was like you had a block and there was like three guys pulling it, and then you slowly put the what's it
Ah,
called, like the,
true.
that was a great diagram to explain this idea of like what is knowledge, like, or how do you gain knowledge, right? Like you kind of extract some
Mhm.
sort of level of abstraction, and then you can build on top of those abstractions. And I think that relates a lot more to what you're talking about, where in architecture you do have these kind of like established like level of abstractions that then you can like tap in where whatever phase you're in, where you have like specialists that use a certain level of abstraction
Yeah.
and so on.
Yeah, so
Um,
for example, you know, many people are saying, you know, like we can use AI to solve all these kind of big societal problems, you know, or problems that we deal as society, you know. And it's like, how are you going to do that if you just have models that are trained based on past solutions that obviously they
yeah.
didn't work, you know? So how is that model going to do that, you know? So if I'm just showing images of a block that is just through brute force dragged, you cannot expect that model to realize that there are wheels underneath. Yeah, you can't. You have to show examples. Like for example, GPT, it's able to do that just because while it's also saw not GPT, I mean Journey or DALI, it's kind of
Yeah,
models.
yeah.
You have in the training set, you have also cars, probably objects with some wheels underneath. So that's why it knows. But if you were to only show that model examples of a block and brute force dragging it, the model is by itself is not going to get out of that kind of domain of the data set. So it's going to be just that. Yeah? So then, you know, you need other processes then. Also, you know, I heard people like talking about, you know, climate change. So you can use AI to solve climate change issue. What, how? If you just limit it to
Yeah.
the past kind of models of how we try to solve it. You're just going to have an AI that gives you more iterations, variation of the ideas that you already explored in the past. Yeah, but it's not necessarily going to give you a completely new novel model, novel idea. To have it more novel, then that system has to engage in a sort of process of iteration. If I like, I generate an image, and as a model, I should be able to judge somehow which are those values. How do I judge? And the result to say, okay, well, this is not really good from this perspective, so I have to go back, generate another one. Is the scoring the other one? Sorry. Is that scoring better than the initial image? Yeah. and keep iterating until you get to a good result. Yeah. So that's in the case of AlphaGo, they had the idea of the reward function, yeah, from reinforcement learning, So that was something that helped the model perhaps to step out of the training set in a way and start to come up with completely new ways of playing. So I imagine the same thing also here. Like if we say we are trying to have this kind of models that very fast they are giving us things. So for example, AI for renderings, like when it comes to text to image, amazing. You don't need like I don't know what kind of logical AI for that kind of problem. Right? It's perfect, yeah, for just create very fast visualizations and renders. But if you say AI for solving certain problems, what we have right now, we cannot really claim that the AIs that we have right now, they are solving certain problems, yeah, like creative problem solving.
Yeah. And I think I actually heard recently from Phil Bernstein, who's a Yale professor in the School of Architecture. And he put it in like a pretty like simple, easy way to understand. He said like these image generator models are provocative, but they're not solutions.
Yeah.
And I think that makes a lot of sense, especially with what you're saying. And like this holy grail of AI being able to find the novel solutions. I think that's kind of what everybody's chasing, or at least like these big companies like DeepMind and OpenAI, where DeepMind created the what's it called? The AlphaFold
Yeah.
model, like for
Yeah.
science. So this idea of being able, okay, if we use AI to solve these science problems or to establish some like foundational knowledge of like some science,
Yeah.
can we then use them and take them to actually go and speed up the progress of science? And that seems a lot more interesting than just focusing on like one
Correct. Yeah.
single area, right, or of image generation. But I don't know,
Yeah, but
do you have
that's
thoughts on that? Like, is that
yeah,
something that,
for me it's the same thing. Like in some presentation right now I didn't show this, but I used to keep on showing that quote from Jan LeCun where he's saying impressive yet shallow, and he's explaining like how these models are he's giving this analogy almost like, or this kind of picture, like you have to think of this model almost like mirrors. They are able to mirror perfectly or to render perfectly reality in a way. A mirror doesn't understand necessarily reality. It's able to reflect correctly the reality, but it's not necessarily understanding reality. Its understanding of reality is as deep as the mirror in a way. Yeah. So that's how we have to think of it, like more than try to project in a way this more claims on this kind of models. They're not yet there. Are we going to get there? Yeah, probably we are going to get there. I don't think I have a doubt that we are not going to get there. It's just that if we judge the models that we have today, they are very impressive. Yeah, they are very impressive, but they are shallow in their understanding. Yeah, so we have to be careful with that. Yeah. And now I don't know what's for me, like it's exciting when it comes to AIs that are able to solve problems, especially like AlphaFold. I think that's a super cool idea. I think there are so many medical problems in this world that very often in a way the way that you have treatment is depending on demand in a way. If there are enough people to be profitable to have that kind of medicine in a way. And if you're unlucky and you have some very rare disease that not enough people have, and suddenly there's no incentive for somebody to create a drug for that. Yeah, suddenly you realize that I have to spend my life with this. I have to just go through life like that. I think with AI, suddenly that kind of price of discovery is going to drop down like crazy, and suddenly we are going to have medicine that actually is super customized to everyone's needs in way. And that's going to be something amazing now. So that's purely like super pragmatic in that aspect. Yeah. Now, when it comes to architecture, personally, I also think that we are going to start to learn perhaps that we had a lot of misconceptions about space, about how people use space. Once you are going to have AI and you're going to be able to assess in a way how people use spaces, you can track things and so on. And I'm not talking here about like, something like, scanning spaces and so on, but somehow a way of measuring, how spaces are being used. Can you predict perhaps how spaces are being used? Because right now what's happening is all the time we build a building, we wait through the process of building it a couple of years, and then another couple of years to get feedback, if the building is used properly or not properly. But if the building is used the way we thought it's going to be used, and we realize it's not, so that's for sure has an impact on the way that, or if you have the belief that the space environment has an impact on the well-being of people, then you're going to say, yes, AI is going to help us with this, If you don't, probably not. Personally, I see that, yes, a well-designed space actually, matters a lot. And I say this because personally, I'm quite influenced by the spaces that I'm in. If I'm in a room that is very depressing, I can feel that, in my mood, that I'm going to also start to feel depressed if I'm staying for too long there. So that has an impact on the well-being. So well-designed space then is going to be very important. And if AI can help with that, then I think it's really amazing. And also, like, if it's possible to design well-designed spaces while having a low cost, because right now we have spaces that are very well designed, but not everyone can afford that. So then we have this no problem.
Yeah. So Daniel, we're here over like an hour. We can close it up, but it's really interesting conversation. I can talk about this stuff all day.
Same here.
And so I have a question, like, what is it that like you're most excited about with all kind of like this development that is currently happening in AI? And like, what is like the thing that excites you the most? Maybe like the possibilities that you see down the line.
Yeah, for me personally, and I can speak just from my perspective, I'm having a hard time, to try to make predictions about overall societies and stuff. But for me personally, I like to get my hands dirty to do things. And for me, like we are going to live in a world of abundance, in a sense of like, if you have an idea, you can execute, you can do it, So for me, that's super amazing, because I had so many ideas that, I don't know if you remember, there was at one point a discussion with a digital future discussion, and there was Neil, Patrick, and a few others. And, it's always like this kind of question from the kind of research that I'm doing, always this kind of question of what about this pragmatic aspect? And it's like, well, it's not that I don't care about those pragmatic aspects. It's just that I only have one life. And to be able to develop all these kind of things takes a lot of time, So it's just that, okay, right now I'm more focused on aspects that have to do with creative AI than super pragmatic aspects, But it's not to say that I'm not interested in those things. But I think now with all this kind of AIs and all this kind of like, augmented kind of coding editors and so on, like suddenly, probably you start to open up the possibility of actually we are going to be able to do all these kind of things, So because I can easily, like, it's not going to take me now like 3 days, let's say, to write or to create an entire interface for something, because I have to code it myself. I can do that in 1 hour, maybe even less than that, So suddenly, the speed of that is going to increase. So it's going to allow us then to explore all these kind of ideas that we were thinking about, but maybe we didn't have, the possibilities of doing, So for me, that's the most exciting thing. I'm super pro. I'm very optimistic in a way as a person. So I'm always excited to see progress, to see things happening, amazing things happening. And in the end, I think that's also something that, people, they have to. I think Elon Musk, like he's saying this kind of stuff where, life cannot be about only solving problems. Life should be something like that you feel excited when you wake up. You have to feel excited about, doing something, So personally, I'm so excited, like to even just to try, just to do certain things, just to know that I was able to do that, and wow, it's working this way. Interesting, So just that kind of learning for me is super exciting, So I think that the world that we are going to live in is going to be full of these kind of opportunities, and each one of us, we are going to have that choice. If we want to explore in a way all those ideas that we had in our heads, now we can do those ideas, And I think we need more of that, because also in architectural profession, for example, my opinion is that, we constrained a lot the talent pool of candidates for architects or for architecture students in a way, based on are you able to hand draw or not, And suddenly, you start to say, well, you're not a good architect if you're not able to draw. So you cannot get into an architecture school if you're not able to draw. And for me, that's such a waste of talent, because my opinion is that well, you might be a very good architect. It's just that, well, yeah, you're not very good at hand art. So suddenly
Yeah.
you pushed away, all those kind of people that could have bring, a lot of amazing ideas and push the field forward with ideas that they had, just because they didn't have the skill of drawing, So I think also here it's going to be the same thing. Like we have perhaps so many people that have amazing ideas in society, but they didn't have, the skill of coding or this or that. And suddenly you're going to see those people, coming in, all those ideas, we are going to be able now to benefit everyone on the entire society. We are going to be able to benefit of all those ideas. Some of those ideas are going to fail, and that's great, because that's how we train through good versus bad ideas. So you have to explore them, just test it out. At the beginning, maybe it sounds like an amazing idea. I'm going to spend 2 days on it, and then I'm going to laugh at myself how stupid the idea was, but that's fine. That's how you train through good or bad solutions. So I think for me, that's the most exciting thing. This kind of ability that each one of us, we are going to have to actually develop any kind of idea and produce any kind of idea that we can think of.
Yeah, and I think it's Sam Altman or one of these guys that they're trying to reduce the cost of intelligence, so it's almost like electricity, right?
Yeah, yeah.
And if that does happen, or if you have the ability of doing that, then yeah, everybody can essentially, if they have ideas, prototype and see if it works. And that's going to be interesting, because that definitely opens up a lot of possibilities of new startups or people solving
Correct.
problems in ways that weren't possible before.
Correct. And I think it's the same idea when we were talking about medicine. Yeah. So I think even if you look at certain problems in society that perhaps they are not so black and white in a way, but many times those problems are not being solved just because, well, there is not enough demand in a way for a company to be able to run, to be profitable, to have a product, to be able, and not even we're not even talking about making a gazillion of millions of dollars or something. We're not talking about that. We are just talking about purely just that company being able to run, to keep the light on. So there are certain problems that they are so niche in a way. So just a few people deal with that problem, that no one is going to solve that problem just because of that amount of demand. But when you're going to have, in a way, everyone can develop, in a way, these kind of tools and apps, in a way, suddenly you can say, well, yeah, it's the cost of me generating those kind of tools is so low that rather than just, I'm not going to have a company that has only one app, but I'm going to have perhaps 10 apps that solve 10 tinier problems, And like that, in a way, I can manage it because I have all these kind of, tools that can help me manage something like that, And suddenly we are going to have, in a way, this kind of solutions, in a way, for a lot of problems that right now they are just pushed aside just because there's not enough demand, and economically it's not feasible in a way, But suddenly we are going to have solutions for all of this, And this could be also at the design level, many times, I'm thinking about I would love to have this kind of design, but guess what? These are the only designs that are available right now. So no one is trying to do a sort of design, object design, that personally I would be very interested in, just because there is not enough demand. So those people are not going to start a business to do that. But when you're going to have reduced cost of intelligence and manufacturing, all that, suddenly you can address those questions, and you're going to have so much customization,
Yeah. And and then to close it up, I don't know if you've seen, but speaking of foundational models, there is a company that's developing a spatial foundational model that just came out of stealth mode by Dr. Fei Li from Stanford. And it's kind of interesting because it's not architects that are creating this company. It is computer scientists that are developing a spatial foundation model, which I'm assuming is going to lead to some sort of base of intelligence for robotics and things like that that can later be used. So that's really exciting. Hopefully we'll see how it can be applied into architecture. I'm curious to see. But
we should focus on creating architectural foundation models. Like, I don't know who's going
Yeah,
to
we
come
need
up
to
with that,
raise
but
like $125 million
yeah.
for that.
No, I
Uh,
think probably, it's going to be something that, a bunch of people from the field have to come together
yeah.
and try to work on that, probably because somebody from computer science, they might, but probably their incentives are going to be different than what's important for us as athletes.
Yeah, exactly. All right. Daniel, we're gonna close it off. Thank you so much for this. This was really interesting. Really enjoy the conversation and the presentation. Yeah, I'm looking forward to see you say you have some releases coming out.
Yeah,
So we'll stay in touch and see what you're gonna come out with.
yeah,
And thank you for sharing this. Thank you for sharing your knowledge. Like I said, I think it was like 2021 Digital Futures that I found your work, took the workshop, was really interested. It was kind of like fascinating to see how you approach these or how do you approach like AI in a creative way. And I think whether it's practical or not, I think it's really interesting to see how people come up with new solutions. Because at the end of the day, like that's what's gonna happen. Like you need people to think in new ways. Otherwise, like if nobody tries it, then nobody's gonna know what happens.
right. Yeah.
Yeah, so thank you for that. Thank you for being an inspiration. And yeah, hope to see what else you come up with.
Thank you for the invitation, and I really enjoyed it. So good luck. Yeah,
All right, awesome. And have a great rest of your
you too.
weekend.
You too.
All
Bye.
right, bye.